Hello, Professor. This is Vivek Tripathi. Um, Now I'm going to talk about the algorithmic component we built. This algorithmic component um, was built to uh, implement a strong user authentication and identity validation process. Now, for e-voter registration, when user logs in the first time, um, user has to go through um, registration of mobile phone, which is done using OTP, one-time password. Then user's speech is stored, recorded, and that is stored for future authentication. User's face is captured also, and that is also stored for future authentication in future sessions. We also wanted to do OCR of state ID and identify user's identity and name and date of birth on the state ID card, but we couldn't achieve it due to time limitation as well as team's expertise with OCR technology. The next step is credit file based questions, um, which user has to answer, and that validates user's identity. And the final one is application sends a mail-in OTP, one-time password to the registered mailing address of the user, and that way we make sure that a user is physically located at that address. So this whole process is uh, to make sure that user or voter is who he is saying he is, and next time onwards when he logs in for registration or voting, we can authenticate with confidence um, the same user. Passwords, we did not want to use passwords because that's a source of breach, and users usually forget password either, or they share password with other people, or they use common weak passwords, which is basically another problem. So we tried to avoid all of that, and we designed the component this way. Now the algorithmic component is basically, this is the concept, and to implement it, what we have done is basically user starts authentication process or registration process. And The first thing is that after OTP, successful OTP, we capture face image, and then we capture a speech of the user. Once that is captured, API call is made to make sure that the face image, the captured image, has a face in it, and it doesn't have more than one face in it. So all that validation happens, and once that is validated, the next step is that um, if it is a registration process, then it will call the APIs to create profile for speech and face, and it will store the data, the face data and speech data into the profiles. Now, after creating the profile and um, registering the data, profile has to be trained. After that, that method is called. Once a profile is trained, it's ready to be used for authentication. Now, there are other ways of using Face ID or Speech ID, which does not include profile. It's simpler to implement, but it's not robust enough, because when you create a profile, you can keep adding more and more data uh, to the same profile, and you can retrain the model again, and that way the prediction or um, the results next time authentication results get better. So every time you add more data, it gets better next time. So to achieve that, first of all, we used profiles. And the second thing is that since these APIs are not 100% reliable, there are issues with these APIs, especially Face API, and not just Azure Face API, other recognition models, machine learning models for face have biases in it. So we wanted to avoid that. And to avoid that, what we have done is that instead of relying on each API separately, we combine the results of a speech API and face API. And what we have done is that we call on face data, we authenticate, and if the confidence level is more than 20% for face, we take it as positive and move forward. And the next step, we validate the speech data. And if the speech data is also more than 20% confidence, then we take that as well. Um, for this project, we have done this, but the speech recognition has better performance compared to face recognition. So in most of the cases, if it's very likely that if somebody is trying to impersonate someone else, uh, speech would be able to catch it. And in case of same person trying to authenticate with his speech, is very less likely compared to relatively with his face that it will fail. It fails in scenarios like where there is a lot of background noise and things like that. In those scenarios, it can still fail. So to avoid all of those scenarios, we took this approach where we are combining the um, collective confidence score of these two API calls, and collectively, if it is more than 70%, then we know that this is the same person. And what we're going to do, we're doing is that we add that newly captured data into the profiles as well. So this will improve um, few in future. It will improve the authentication, and it will be better every time data is added. If it is not greater than 70% collectively, then we check if it is greater than 50% collectively. If it is greater than 50%, we assume that it's the same user, and authentication is successful. In case it is less than 50%, then it is treated as failure, and authentication is denied. So um, mm, this algorithmic component we built is using several APIs. It uses Talio's mobile OTP API. It uses um, 7 methods of Azure Face API, and 4 methods of Speech API for creating the profile, for populating data in profile, for training the profile, for authenticating. So all of these collectively make 11 API calls for this authentication process. Registration and authentication process, and it makes it a robust solution for authentication. So that was all on algorithmic component. Thank you very much.